everybody. Welcome to the Ubuntu Summit. Welcome to this session on MicroCloud. My name is Eric. I'm the director for MicroCloud at Canonical. And we have a couple of members of the team here, but I want to introduce you to Miona Aleksic, our product manager, and Tom Parrott.
Hello.
So the session is going to be very simple. I'm going to talk a little bit about the product, and then we're going to have a live demo. Tom is going to make some we're going to, everything you're going to see is going to be happening on this little cluster, nice cluster that we have. And then at the end, we're going to have time for questions if you ask. So if you don't know what LXD is a virtual machine and system container manager. That means it allows you to launch instances wherever you have it installed. It can be very simple, so it can be a simple installation on your laptop, and you can launch instances there. Or like we have it here on stage, you can cluster several machines together. And once this is done, you can actually command the whole thing from any single one of these hosts. So 3 is the minimum for redundancy, but you can scale this up to about 50 nodes. It is completely API driven, which means everything that you're going to see command line done by the command line or the API, you can also do virtually, and it launches images that are found on the cloud. Next one. So you're probably familiar with virtual machines already. So virtual machines allow you to isolate workloads and run different types of workloads on a big machine. You are also probably familiar with OCI or aka Docker containers, so which allow you to isolate application workloads on the Linux box. So what are system containers? They're actually a bit of the best of both worlds. So they allow you to run full Linux workloads on with the same kind of lightweight footprints that you have with OCI. So run full, they have to be Linux, of course, but they're entire machines running on your machine. So again, coming back to LXD, so LXD allows you to launch instances, but it also allows you to manage the environment in which this is happening. So LXD allows you to manage storage. So you can define multiple storage pools. LXD is compatible with multiple file system types. And you can also use LXD to help you organize and manipulate networks. So you can use, if you have a bridge on your host, LXD can use it. But you can also use LXD to create more bridges, and they can even be managed, which means that LXD is going to run the HTTP for you. It's going to have naming services and all of that. So just before. So this is for single instances. If you have a cluster, you might want to use distributed storage or distributed networking. So we have, so LXD already had an integration with Ceph, which is a distributed storage solution, and Oven, a distributed networking solution. But if you ever tried installing those, it's quite complicated and it can be difficult and it can be a daunting task. So what we have done is, of course, over the course of the last few months, is create a very simple setup for you to install all of this. So working in collaboration with the OpenStack team, we now have OpenStack, which is a snap-based Ceph installer. We have a snap-based Oven installer, and we created an overarching snap, which allows you to federate all of these together in what we call MicroCloud. So MicroCloud is a very simple, easily installable, complete cloud that can grow from very small to very big. And without further ado, we're going to demo it right now with the help of Tom.
Thanks, Eric. So as you can see, we've got the MicroCloud box in front of us. This is made up of 3 motherboards, each with an NVMe drive and a SATA SSD. They're connected to this uplink router here on a shared L2 subnet, 192.168.20. And we're going to, we've got MicroCloud already installed on these systems. And what we're going to do is we've got 3 VMs, one on each host, that are just empty Ubuntu VMs. And we're going to go and set up MicroCloud. What we've done to the VMs is we've attached 2 disks to each of the VMs to simulate a local ZFS pool and a remote clustered Ceph pool. So if I go out of that now. So here, can everybody see that? Is that all right? Cool. So I'm now SSH'd into the top motherboard there, Micro 01. And I'm now going to, and I can see I've got the 3 VMs, demo 1, demo 2, and demo 3. And if you look on the location column, you can see they're running on the 3 different micro cluster nodes machines in here. So I can switch first into demo 01. And if I show you what's installed, it's not very much, but at the moment we've just got a blank system with LXD, MicroCef, MicroOven, and MicroCloud. And I can do this to set up MicroCloud. And I have those 4 snaps installed on every single node already. But apart from installing them, I haven't done anything else. So the first step when setting up a MicroCloud is it's asking, it's taking its own IP address and it's saying, I want to go and search the network using multicast to find other MicroCloud members on the network. So it's just asked me to do that. And it's found the other 2 virtual machines. So I'm going to press the right cursor key to select those 2 I want to include in my cluster, and I press enter. Now it's saying whether I'd like to set up local ZFS storage, so I do. And here it's gone out to all of the nodes and collected all of the information about any empty disks on those nodes. And I can just start typing and it will filter this result set. So if I filter by 30, I can see that each of these nodes has an empty 30 gig disk. It could be, I can go and individually select them, but as they're all the same, I can just go and press right again and get all of them. Now it's asking me, well, there might be some leftover file systems or partitions on these disks. So do I want to wipe them? So yes, I do. The next one is asking me about setting up Ceph. And I can say, this is optional. You don't have to have Ceph. But if you want a highly available cluster, you need it. So we'll do that. And you can see that the 30 gig disks have now gone from the list and we have just the 50 ones left. So again, I'll accept those and wipe them. Finally, it's asking me about configuring distributed networking. So this is going to be setting up the MicroOven component, and that's going to be creating an overlay network across all of the virtual machines to allow your instances to communicate across nodes. So yes, I do want to do that. When you're setting up MicroOven, you have to specify what uplink network you want to connect to for external connectivity. So in this case, the virtual machines that I configured earlier are bridged onto the main network, and so the uplink router is still that router there. So I will select the same. They can be different interfaces on different hosts, but in this case, they're all the same. So I'm just going to select them. So now I need to tell the microcluster setup, MicroCloud setup, what the address of that router is. So I'm just going to type it in. Like that. And each oven network that I go on to create needs an address on the uplink network for the virtual oven router that it creates. So I need to specify a range of IPs that are available on the uplink network that are guaranteed not to be used. So we've configured the DHCP server on this router to only allocate dynamic IPs in a certain range. And I'm now going to specify a range of IPs that are outside of that. Now, it's important that those IPs, I've given a range there, those IPs are only going to be used by the virtual oven router. They're not used by the individual instances because the virtual oven router performs SNAP. So that's going to allow me to create several networks, not just several instances. We haven't got IPv6, unfortunately, here, so I'm going to skip that part. Okay, so now MicroCloud init is starting LXD, MicroCef, MicroOven on the local node. And then once that's done, it will go out to the network, go out to the other nodes, and it will activate MicroCef, MicroOven, LXD on those nodes and configure them to cluster together. There we go. As part of that process, MicroCef will create OSD pools on the disk that I've specified. So it'll create the OSD pools on the SATA SSDs. And it will create a ZFS pool on the NVMe disks that I specified. And it will then use the uplink network to configure oven. Okay, so one of the virtual machines has joined now, demo 02. Usually takes about 2 minutes or so in total. Come on. It's going to go eventually. There you go. And so the final step, what it's doing now is it's configuring LexD. So I don't know if you've got any experience with LexD, but it will be telling LexD to use MicroCef and MicroOven for its storage pools and for its networks. It will be configuring the default profile so that any instances you launch are automatically using that oven network and that Ceph storage pool. Okay, that's done. You've now got Ceph and oven and LexD configured on a 3-node cluster. So let's have a look at what that looks like. So I type LexD cluster list. I'm just going to make my screen a little bit bigger. There you go, so you can see it. So we can see there's 3 cluster members, and demo 1 is currently the database leader. If I have a look at storage, I can see it's created my local ZFS pool and my remote Ceph storage pool. And if I launch now a container, it will download the image. Okay. So what this is doing now is this is downloading the Ubuntu, the official Ubuntu Jammy image. And when it's finished downloading, it will unpack that tarball file system onto a Ceph volume. Now, the way LexD works is that it will create first an image volume. And from then it will take a snapshot of that image volume to create the actual instance volume, the C1 that I've created. The reason we do that is it avoids incurring the unpack time for every instance you launch. So this one will take a little bit longer, and then I'll launch a C2 in a minute, and it will be a quicker launch time. And you say you only pay that unpack time once per storage pool. And what this is doing is, as I'm unpacking this image, it's writing it to all 3 SATA drives across the cluster, because Ceph will be replicating that. Okay, so let's have a look. Okay, so that's running. So if I launch now C2, this won't incur the unpack time. It's going to take a snapshot of the Ceph image volume and create a C2. Okay. Okay, right. So we'll just let it start up and get an IP address. So you will notice that these 2 are running on, if I just expand my screen slightly, there you go. You can see that C1 is running on demo 1 and C2 is running on demo 2. And they've both come online, done DHCP, and got an IP address from oven. So that's setting up MicroCloud. Now, if I just switch back, the other thing I'd like to show today is actually running on the main MicroCloud cluster, and that's VM live migration. So I'll just switch back to it. And I also want to, as part of that, have a look at the GUI that we have next to UI. Right. So this is running, I'm connected, you can see at the top, I'm connected to 192.168.20.10, which is the top motherboard, but I can connect to any of them and they're all running the same UI. And I've switched into, so that was the default project that that was the demo project that we were running earlier. And that was the 3 VMs that I was just controlling as part of the setup. If I now switch to a different project, I can see the next stage of the demonstration. So projects are a way of collecting together different instances for different types of use. So let me start those. So I can select those 2 and do start. Okay, so they're up and running. So whilst that's starting up, I will click in to here. And I can start to see some usage information about the container. I can see it's now got its IP addresses. And what I can do is I can go straight and actually enter into the container directly here. And what I'm going to do is just going to start a ping going to V1. Okay. If I put that to one side. Just sort my screen out a little bit. And everybody see both screens. So we've got a ping going here that's pinging from C1, which is running on one host, to V1, which is a virtual machine running on a different host. And now what I'm going to do is I'm going to move this. So let's see project switch. I need to switch to the same one. Same project. Okay. There's the C1 and V1. I'm going to do let's see move. Now I can see if you look at the location field, just make this a bit bigger. Location is running, C1 is running on the top board, micro 01, and V1 is running on the bottom, on the middle board, micro 02. So if I now, let's move it to micro 03 without stopping the workload. Okay. So we should see this ping keep going because the virtual machine V1 should be reachable for the whole time it's being migrated. There's a small blip at the final point where the state is transferred. Okay, let's move. Did we lose anything? 79. Yeah, look, we lost 80. Yeah, let's move it back to 2. See. There we go. 101. A couple more there. So 98, 99, 100, 101. And if I switch into the virtual machine, I can say uptime. I can see it's been running for 2 minutes because it hasn't been rebooted during the live migration. And that's our demonstration today. Any questions?
So all of this is available in form of snaps, but the code is also available. This is free and open source, so everything is under canonical, on GitHub under canonical. Any questions? Well, we just demonstrated that. So we demonstrated the fact that now all of them kept running, but we also have options for to monitor the state of the system. So we have the threshold. So if it's been out for a certain number of seconds, then we can migrate the load.
Yeah. So the LXD itself uses a Raft-based embedded database called SQLite. So the LXD cluster itself, if you have 3 nodes or more, is highly available. And then the MicroCeph and MicroOven snaps, respectively, set up their own clusters, which are highly available. So they use the MicroCeph uses its own SQLite-based cluster system, and then MicroOven configures Oven's its own Raft clustering.
Can we migrate without the Ceph cluster?
Yes.
And then how to specify the platform or the specific virtual machine?
Can you
set up the specification for the virtual machine?
Yes. So you can specify things like how big the disks are, how much what the memory limits are, how many cores. Yes, and you can create custom volumes of different types.
Right.
Oh yes. There we go. Yeah. So if I go back to instances, I can do correct.
But the question was, can we migrate without Ceph?
Yeah, that's the first question. Without.
Yeah. Oh, yes, you can. Yes, it will use local. It will replicate. It will take a bit longer because it will replicate local storage.
So they will transfer from the bare metal one to the target.
Yes. It will replicate the root disk whilst it's still running. Then it will pause the virtual machine, do a final state transfer, and then bring it up. It's quicker with Ceph because you haven't got to replicate the actual storage.
Storage already there.
Yes, you just switch it off. Yeah, exactly.
with the computer.
Yeah, exactly.
Is this alternative to Proxmox?
Yes, in some form, yeah.
Do you need to do any special setup if you have a single remote storage? Instead of set, you have a remote storage setup. Do you need any special setup on that?
So we're currently working on another integration with a distributed software storage solution. If you have an external, would it be like a storage array or something like that?
Yeah, the storage array.
So you can, the options are limited in the sense that you can define LUNs there and you can hook your LUN to the servers, but we don't have currently a way of sharing that with Riven. So you would need to attach different LUNs to the different machines. Is
I have a question about pricing of networks. Is there something to be known and I get and like
So I can't hit.
are there limitations if it's air gapped? So if it's air gapped, you of course need to have all of the software available to install.
Yes.
You also have to have most of your own images because the system cannot go outside to get them, but you can create that. So you can predefine, pre-download images, and you can have.
Yeah, I believe as well. There's the Snap Store has a Snap Store proxy, which I think helps with air-gapped environments.
Now we have a couple of times. If some of you want to come and see the setup, my message is welcome to come on.
Thank you very much.
Yes. Thank you.